Captchas. We all hate them and dread seeing them pop up on websites, but what if you're making a game using only Captchas? Well, that's exactly what I did for my game that I made in 48 hours for Ludum Dare 50. If you don't know what Ludum Dare is, it's a game dev competition where you get either 48 or 72 hours to make a game, although this time around Ludum Dare also added a more relaxed, no time limit category as well, but I won't get into that. When the time starts, a theme is announced that you're recommended to incorporate into your game, and from that point on, you're off to make your game. Now again, I did the shorter 48-hour version, which meant I had to work alone and make all code and assets inside this time frame. I also streamed almost my entire game development of this game live on my Twitch page at twitch.tv/turkeydev. Unfortunately, Sunday was spent taking and editing pictures for the game, so I didn't stream that, but I did for Friday night and Saturday, so still lots of content there. Okay, enough talk and intro, let's get to how I actually made this game. The theme for this Ludum Dare was Delay the Inevitable, and I proceeded to spend the first 15 or so minutes of stream brainstorming and coming up with ideas for the game to make. Usually this takes me anywhere from 30 minutes to an hour, and because I had no prior plan for my unconventional game engine I was going to use, I very much expected this to take even longer. Somehow though, I very quickly came up with the idea of making a game where delaying the inevitable meant just delaying a timer from reaching 0 for as long as possible, whether that be adding time or slowing it down by completing various tasks. From there, the idea kept expanding to include the idea of a web-based game where when the time reaches 0, the page refreshes, causing you to lose all of your progress and have to restart. Then to top it off, I decided to make the challenges that affected the timer be Captchas and web verifications. Because this was a web-based game and a single-page web app, I decided that my trusty React framework would make a great unconventional game engine. With the idea, language, and engine now out of the way, it was time to move on to actually setting up the project to make the game. Now if you don't know, I'm not the biggest fan of Node and its Node modules, and because of that I tend to not use scripts like create React app because I like slimming my projects down and having a greater control over what I use. Because of that, over time I've learned what core dependencies I need and tend to just copy things from existing projects. I probably should just make my own project init script, but that's for another day. With the project base files now set up, it was time to work on the base site code. Over the past few months I've been working on my own library of common React components I use and a more consistent theming system for my existing web projects. A quick page setup with that styling and printing hi to the page, and the web app is ready to make a game with. First up was to add a timer and page reload mechanic. Adding a ticking timer and page reload when it reaches 0 is easy enough. Just save the current time left as a state variable, and then using this use interval hook I have in my custom library that basically just wraps a use interval, we can tick down the state towards 0. Adding on a use effect that tracks the state and reloads the page when it reaches 0, and then also displays a formatted version of the state variable, I now have a working timer. Unfortunately though, as it stands, this is very inefficient as how React works. Any state change causes the component and all child components for the state to re-render. So given our time left state is in the root component of our web app, and it ticks down every 100 milliseconds, that means our entire web app re-renders every 100 milliseconds. So I will need to address this, but that will come later. With that though, the timer and core reload mechanic are complete. Next up, it was time to add the first captcha to the game. To start off, I decided to go with the simple I am not a robot checkbox that you have to click. Normally this captcha uses a lot of analysis and mouse movements and such to determine if you're a bot or not, but that's way too complex for something like this, so all this will be doing is just be a checkbox. Again, starting off simple and using this to be more or less the setup of the groundwork for the game and logic to provide an easy captcha that will act as a start new game action. One captcha down, now it's time to start working on ones that would provide more of a challenge for the game. I decided to first remake the letters input captcha where you are given random letters that have been distorted and random lines and other effects on top of them. The idea of this is that humans can easily recognize and decipher the letters, whereas bots struggle. Nowadays bots are probably better at deciphering them than we are, but nonetheless it was time to remake it. I started with a canvas and rendering out random letters to it. I then took those letters and applied both random colors and rotations to make them all appear different. Normally the traditional captchas also switch up the font size and font itself, but for simplicity I opted to skip them. So at this point the letters are displayed to the canvas, and the user can use the reload button to get new letters at the cost of time, but this isn't too difficult to decipher, and for that I decided to add random lines and dots on the screen that over time as you progress would increase in number, making it harder for you to read the numbers. To do this, I just simply picked two random x and y coordinates on the canvas and drew a line between them. The number of lines drawn starts low, but I use this math expression to increase the number drawn as you get more captchas correct. And with that, after adding a little logic to check the user's input, the first real captcha was complete. The second captcha I decided to add was the ball roll captcha, where you have to use the arrows to correctly roll and align the ball. I don't really know the science behind this one and why it's hard for robots, but nonetheless it's a captcha that I've seen a lot. Animations aside, this was fairly straightforward to make. I added two buttons with arrows in them on either side of a center div. The center div had a solid border and a border radius that is half of its width and height to make it show as a circle. Next, just add a state variable that tracks the ball's rotation and applies that rotation to our div that is acting as our ball. Then make the arrow buttons change that rotation state, and now our ball and its inner text that will eventually be replaced by an elephant or a penguin will also rotate with it. The only missing animation was the little bounce the ball does in addition to its rotation. I struggled to implement this and thus ignored it initially, but later on I did come back and solve this. I simply added another div around the ball and used another state variable to add a remove a class. This state variable is set to true when you clicked on one of the arrows, and when applied, caused the div to do the little bounce animation. Once complete, the state variable was then set back to false, allowing further button presses to keep applying this animation. With the ball rotation captcha complete, I moved on to remaking two web verification challenges and solving a small math question and typing in a random word. Neither of these are captchas and instead are just very low-level bot prevention strategies, but they will add some nice variety to the game. Both of these are fairly simple, so I won't spend too much time on them, but I did add some nice difficulty scaling where the math questions progressively add more numbers to sum together as you progress, and the word input gets longer and longer as you progress as well. After these, I got the first captcha I hadn't seen before, where you attempt to slide a puzzle piece to a corresponding empty space. I started by simply copying over all the canvas logic from the random letters input captcha and proceeded to mock up drawing a puzzle piece-like object. I accomplished this by simply drawing lines for the piece edges and using arcs for the center-like interconnects. There is then this helpful closed path method that allows you to complete the puzzle piece shape and then give it an infill color. This color was also reused at different X locations with a dark background to symbolize where you had to slide your puzzle piece to. I then utilized a state variable to control the X position of the puzzle piece that was controllable via a slider input, that then also utilized a use effect for when the state variable changed to then re-render the canvas and show the puzzle piece at the updated position. The submission and check logic is also thus pretty straightforward, as when the user clicks submit, it simply checks the current X position and the corresponding X position of the goal location, and if the difference is close enough, the user is correct. With the core logic complete for this captcha, all that was left was to add in this weird and confusing background, which I suppose are there to make it more difficult for bots. The last two captchas I implemented are probably the most well-known and likely hated ones, and that's the image selection captchas. The first gives you 9 different images and asks you to select all that contain a certain object, while the other gives you one image with a 4x4 grid overlaid onto it and asks you to select all the cells that contain an object. I saved these for last because they are a bit more difficult to implement, but I also was planning to have images taken by this point to use to actually build them, but sadly that was not the case, so instead I choose colors or a random image pulled off Google Street View as a template. For the multiple images, I first structured out the look of the captcha with a 3x3 grid where the images would go. I then added logic for creating a group of images that could then be picked from for the user to see and select. The images were grouped by which thing they showed to make the overall logic a bit easier. Again, I just used colors to represent each group until I got real images. I then implemented the logic when you select an image, it would mark that as selected and shrink the image so that you could get the classic selection animation and look complete with a blue circle and check mark. To complete the logic, I then made the captcha choose a random group that it wants you to select from, and then when you hit submit, it then checks all the images to make sure that the ones they have selected are in the group at once, and the ones that are not selected are not in that group. The single image works much the same way with the random group select, but I instead provided the indexes of each cell that should be selected when the user submits. Beyond that, to get the cells to work, I just overlaid the grid on top of the image, and when you select a cell, it animates the cell's border to become thicker to give it that classic selected effect. And that completes the captchas. The rest of my time on the final day was spent taking and editing pictures to be used in these captchas, and playtesting to improve the overall game experience. Changes made included adding various difficulty implements like multiple ball rotations and multiple puzzle piece sliders, and changing the time adjustments for when you get a captcha right or wrong. I also made the Captcha slowly start moving around the screen instead of always just being in the middle. One non-visual change that I made that was mentioned towards the beginning of this video was that I made the entire app not re-render whenever the timer changed. To accomplish this, I used two memos. One held all of the functions that were used to manipulate the time. Those don't change, so that one's pretty straightforward, but the other was used to hold the currently displayed Captcha. This one only changes when the shown Captcha and number of challenges are completed change. Using these two memos, which only recompute when needed, allowed me to keep a bulk of the page from re-rendering when the time changes many times a second. And with that, the game is complete. I will link the Ludum Dare page, which is both the game and the source code link in the description below if you want to check it out for yourself or even the code. Overall, this is probably one of my best games, if not the best game I've made, and I truly feel good about it too. Anyways, hope you guys enjoy the game, and hopefully you guys have enjoyed this video. I'd love to hear what you guys think in the comments below, but that's all I have for you guys today. I'll see you guys next time. Peace out.